My name is Akshay and this is Half Sleeves.
Let's train our encoder and decoder to learn the first job now, which is preserve the content of the content image, especially the content which is important to the style. This we can achieve in two steps. First, we want the output to look like the input picture. So we will apply a simple content loss. Let's say this mesh shown here is our input picture. We will take average pool of pixels of this image with kernel size 10 and stride 1, which means we will take the average of 10 by 10 blocks from the picture and then move right with stride 1. The big blue block indicates the action of taking an average, and the white block on the right indicates the average of those 100 pixels from that 10 by 10 block. We will repeat it till we have covered the whole picture. We will first do it for content image and call the average result as content image averages, and then we'll do the same for stylized image and call the average results as style image averages. Now we have two average results, stylized image averages and content image averages. We then compare these two average results. How close are they? We do that by subtracting one by the other. So if this difference in the average results is less, it means overall the content and the stylized images are the same. This difference in the averages would be called content loss. Less content loss would mean that most of the content in the content and stylized images is the same. But we don't want most of the content. We only want the content which is important for our style. So, to get only the content which is important for the style, we will use a style-aware content loss specified in the above shown paper. Here, we want encoder to preserve only the content which is important for painter's style. And to do that, we input a content image to the generator. The image would go through encoder and produce an output of 256 by 16 by 16, which is called contents of the content image. Because as you know from the previous videos that the job of the encoder is to preserve the content of the input image, and then these content of the content images would go through decoder and produce an output called stylized image. First step is to save the output of the encoder called contents of the content image. The second step is to take the output of the decoder, this stylized image, and feed this stylized output to the encoder and save the output of the encoder this time too. Let's call this output of the encoder contents of the stylized image. Difference between these two saved vectors, contents of the stylized image and contents of the style image, which are of size 256 by 16 by 16, would be the style aware content loss of the encoder. Contents of the stylized image. This vector shows the contents of the stylized image made by the generator. Contents of the content image. This vector shows the contents of the input image. If we want our encoder to only preserve the content which are important for the style, then these two vectors should be same. You must ask why. Well, let's see. Let's say we have a content image with three contents in it: leaves, branches and flowers. Let's feed this content image with three contents, that is leaves, branches and flowers, to the encoder. The encoder will take in this content image and we will get contents of the content image, which will contain all the contents. Why all the contents of the input content image are preserved? They are preserved because we applied a content loss to the encoder, and that's why encoder is trained to preserve almost all the contents of the content image into a vector called contents of the content image. Now, the decoder will take the contents of the content image as input. Remember, as the decoder which stylizes the image is trained, it learns that only one particular content out of the three is important to the style, and only that content should be present in the stylized image for the stylized image to look like the original Monet painting. Let's say that the content important to the style is branches. So we want only branches to be clearly visible in the stylized image and not the other two, that is leaves and flowers. Now the decoder will take the contents of the content image as input and will stylize all the content and leave the content which it thinks is important to the style, which in our case is branches. So it will not stylize the important content and leave it as it is. The decoder is doing so because the decoder knows that only branches should be clearly visible in the stylized image for the stylized image to look like the original painting and not leaves and flowers. So you would see the branches clearly visible in the stylized image as branches are not stylized by the decoder and faintly see those unwanted content, that is flowers and leaves, which the decoder stylized in the final stylized image. But we don't want these faintly visible leaf and flower content because the decoder has already told us that this content is not important for the style. Only branches are important. In fact, the presence of leaf and flower in our stylized image gives us the stylized image which doesn't look like the original painting. So the solution for removing or reducing or fainting the leaf and flower in the stylized image is to somehow tell the encoder to not to preserve the leaf and flower content in the vector contents of the content image when a content image is passed through it in the first place. We do that by passing this stylized image with branches and fainted unwanted content through the encoder. After passing, you get the contents of the stylized image, which are branches and fainted unwanted content. Now, if you take the absolute difference between contents of the content image with contents of the stylized image as shown in the loss function below here, you can clearly see that the loss will be minimum when both the contents of the content image and contents of the stylized image will be identical. And they will be identical when the contents of the content image will remove or reduce or faint its unwanted content, that is flower and leaf. But what does the fainting of the unwanted content, that is flower and leaf, in the contents of the content image mean? It means that when we pass the content image through the encoder will not preserve those content or will fade those contents which are not important for the style. Here, those non-important contents are leaf and flower. So this loss function tells the encoder to preserve only the content which is important for the style and removes and faints the unwanted content in a final stylized image. Another way of thinking about this loss function is that it forces the stylization to happen in the decoder. As a result, decoder will not change the content which are sent by the encoder, and both the encoder and decoder will have to find an equilibrium to find a common ground.
In the next videos, which will be following this video, I will explain the code of the style transfer model. The link to the code of the style transfer model is available in the description.